This is a video lesson for 4.5. We're going to be doing some more factoring, but this time factoring with special cases. Those special cases include polynomials that are called difference of squares, or perfect square trinomials, and difference of squares. So those are two cases we'll be working with. We'll start off with difference of squares. First, we'll define what difference of squares are. We'll see how to identify them. Then we'll see the steps to factor a difference of squares. And then we'll do some examples together. So a polynomial that's in this form here, a squared minus b squared, where both terms are what we call perfect squares, and I'll explain what that is in just a bit. Perfect squares, some of you might already know. Perfect squares. And they are being subtracted, so a minus, subtracted. If you have this setup, so a squared minus b squared, where a squared and b squared are perfect squares, and there's that minus there, you have what's called a difference of squares. A difference of squares. So before we move on to see what that looks like with a specific example, I just want to explain what a perfect square is. So a perfect square is a number that's made by squaring a whole number. So, for example, 16. 16 is a perfect square. It was made by squaring the number 4. 9. 9 is a perfect square. It was made by squaring the number 3. 36 is a perfect square. It was made by squaring the number 6. 81, made by squaring the number 9. The best way to figure out if you have a perfect square is to simply take the square root of your number, and then if it's a whole number, then you know it was a perfect square. So for example, if I do square root of 16, that's 4, so that means that 16 was a perfect square. 4 is a perfect square. It's made by squaring a whole number, so square root of 4 gives you 2. 1 is a perfect square because it's made by squaring, well, 1, which is a whole number. If I were to ask you if 10 is a perfect square, well, what you could do is you could take the square root of 10, put that in your calculator, square root of 10 in your calculator, and you get 3.16. That's not a whole number, so 10 is not made by squaring a whole number, which means that 10 is not a perfect square. So when you're looking for perfect squares, make sure you do that test, take the square root. If you get a whole number, you have a perfect square as your number there. You can probably think of more, like 25. If you do the square root of 25, then you get 5, which is a whole number, so that means 25 is a perfect square as well. So let's go and see how we can spot if different polynomials are considered perfect squares, differences of squares or not. Remember, to be considered a difference of differences of squares, you have to have 3 conditions that need to be followed. So 3 conditions need to be satisfied. It means it has to meet 3 conditions, like a checklist. The first term in your polynomial needs to be a perfect square. So I'm just going to write perfect SQ for square. The last term also needs to be a perfect square. Perfect SQ. And the sign in between those terms has to be a minus. It has to be a subtraction. A minus. So, for example, if I have x squared minus 25, well, this 25 here, if you take the square root, you get 5. X squared, there's actually a 1 in front of it, so it's 1x squared. So 1 is a perfect square. So those two numbers here and here are perfect squares, and they're combined or joined together by a negative. So perfect square first term, perfect square for second term, and there's a minus in between, so that means that we have a difference of squares over here. Okay, and if you take a look over here, x squared minus 49, well, the first term is, well, 1x squared, that's a perfect square. The second term is 49. If you take the square root of it, that's 7. That's made by a whole number. So that means that this is a perfect square as well. They're joined together by that negative, so we have a difference of squares over here. If you take a look over here, you have 9x squared minus 36. So this 36 here, that's a perfect square. This 9x squared is also a perfect square, because if you take the square root of 9, that's 3, and square root of x squared, that's just x, so 3x. That's a whole number there. So we have perfect squares, and minus, and that means we have a difference of squares. Same idea here. We have 1x4 minus 16. 16, due to square root, that's 4. So that means 16 is a perfect square. 1x4, well, that's, if you take square root, that's x2, so 1. Square root of 1 is 1. So that's a perfect square as well. And then there's a minus in between. So that means that we have a difference of squares again. But let's take a look at something that's not a difference of squares. How would I know? Well, if you look over here, you have x squared plus 16. So, yes, we have two terms. This 1x squared is a perfect square. This 16 is a perfect square. But one of the conditions is not satisfied. You'll notice there's a plus here. There's a plus here. There should be a minus in between the two terms, not a plus. So what that means is that this is not a difference of squares. Why is that important? Why do you need to identify if you have a difference of squares or not? Well, there's a set of rules to simplify factoring of difference of squares, and that will only apply if you actually have a difference of squares. So we're going to go and type out the difference of squares factoring rules. That'll make it a little bit easier for us to actually factor them. And then afterwards, we're going to do some of the examples together using that new set of methods that we just discussed. So when you identify a difference of squares, so first of all, identify you have a difference of squares by doing those three conditions we discussed. What you need to do is you need to create two sets of brackets. And then what you're going to do is you're going to determine the square root of the first term, which is usually the x squared term or the x to the power of 4 term or whatever it is. You'll determine the square root of the first term and place the answer in both brackets, in both bracket sets. You'll then determine the square root of the second term, so for example, the negative 25 or the 25, and you're going to place the answer in both brackets as well. And then what you'll do is, in one bracket, connect both terms with a plus, and in the other bracket, connect both terms with a minus. So let's go over these rules together to see how they apply and what they actually mean. So I'm just going to erase some of these here to make some room. I'm going to factor using two methods for these. I'm going to show you the method you already learned for factoring, and then I'm going to show you the difference of squares method. So if I have x squared minus 25 and I ask you to factor that, what this really means is x squared plus 0x minus 25. So you still have a b there and a c here, and you can still do this trick where you want to find two numbers where the product is c, negative 25, and the sum is, well, in this case, b, which is 0. You don't see it here, but you know it's 0x. 0. We don't write 0x because it's 0. You don't have to put that in there. But you could easily find out that those two numbers are negative 5 and positive 5. Because negative 5 times 5 is negative 25. Negative 5 plus 5 is 0. And so you could create your set of brackets and simply put x minus 5 and x plus 5. And that would have worked just fine. But you could save some time. You don't always have to do this. you can realize this is a difference of squares because the first term is a perfect square, the second term is a perfect square, and you have a minus in between. You can make your two sets of brackets, and you can follow the rules below. Find the square root of the first term. So square root of 1x squared, square root of x squared is simply x. So you'll place x in both brackets. Find a square root of the second term, so square root of 25 is 5. Put 5 in both brackets. And then connect one by the plus over here and the other by the minus over here. And now you have a factored form of x squared minus 25. You didn't have to go find two numbers that gave you negative 25 as a product and 0 as a sum. All you have to do is realize this is a difference of squares. So again, same idea here. Let's try the difference of squares methods. So you make your brackets. We know it's the difference of squares because we have 1x squared, so 1 perfect square, 49 perfect squares, connected by a minus sign. Square root of x squared is simply x. Put x in both brackets. Square root of 49 is 7. Put 7 in both brackets, and then connect with a plus, connect with a minus. So by identifying this as a perfect square, you could simply use that trick to factor. You could have used the other method, like I said. You could have just viewed this as x squared plus 0x minus 49. You would have had to find two numbers that the product gives you minus 49 and the sum gives you 0. And you would have found that those two numbers are negative 7 and 7. And you would have simply done x plus 7 and x minus 7. And it would give you the same answer. But now that you know how to do this difference of squares method, you may as well do that. It saves you some time. It's much more rapid. Verifying the work is the same that you did for the previous lessons. So I'm going to do an example where we verify to make sure that this x plus 7 and x minus 7 is actually going to be the same thing as this x squared minus 49 by expanding using FOIL. So I do x times x, I get x squared. X times minus 7 is minus 7x. 7 times x is plus 7x. And then 7 times negative 7 is negative 49. Then I get x squared minus 7x plus 7x, that's 0x. Minus 49. Now again, you don't have to write down 0x, so really this cleans up to being x squared minus 49. And so there we've seen two examples of factoring difference of squares using the set of rules for difference of squares. You could have made it more complicated for yourself and rewritten it as this expanded format here with that 0x in there. But again, it's better to use this set of rules here since it's a much quicker and more efficient way to do it if you can identify difference of squares. So at this point, you should be able to identify if a polynomial consists of a difference of squares using the identifying checklist here, and then you should be able to apply the factoring rules for difference of squares as we've seen below over here. In the next video, we're going to do examples 3 and 4 and then move on to our second special case of factoring.